Hello TaleForges! In this video we'll focus on the VContainer factory implementation, which will allow us to dynamically spawn objects on the scene with inject dependencies. So let's dive in! If you have been following my dependency injection series, you know how game-changing VContainer is for Unity projects. With factories, we can level up and enter more advanced topics, which will allow us to develop our skills and knowledge further. As you can see, I did a comparison of GameObject.Instantiate versus creating a dynamic object in VContainer. There is a lot more code we have to write in VContainer, but in return we can correctly inject dependencies. With the classic GameObject approach, we would have to invoke singleton instances in monobehavior, or use a public method setter after creating the object and pass the dependencies, or create a custom dependency injection handler. Each of these approaches has its drawbacks, which VContainer simply eliminates, mostly bad encapsulation and breaking SOLID principles. The introduction was a bit long, but it was necessary to explain what the factories are used for. I have posted a link to the documentation for anyone who is interested in learning a bit more. So let's start with creating a new script, factory example model. It is a monobehavior class with 4 serialized fields, button, enemy prefab to spawn, we'll create enemy class in a moment, and 2 parameters for the position, spawn position X and Z. The idea behind this is that we will be able to pass a single parameter when creating factory, in this case the position of the object, so I can show you how to do it. For readability, don't forget to add headers, references and parameters. Next, create factory example presenter class. Also prepare the factory example service and leave it empty for now. First, let's implement 2 interfaces, initializable and disposable, add missing methods in which we will listen for button press. But now let's add read-only variables, factory example service and factory example model. We'll assign these variables in the constructor using dependency injection, which we will define in LifetimeScope in a moment. It's time to add and remove onClick button listener in the initialize and dispose methods. After click, we want to execute instantiate logic, so let's prepare new public void method. Inside it, we need to cache spawn position X and Z and pass them to the factory example service.instantiate. Now, before we move on with factory service, we need to implement enemy script. In this class, I will use Hello World Manager, which will be injected in the constructor, to print message in the awake method. You can test this functionality with any registered object. Of course, this only applies if the object scope is correct in your context. Okay, it will be easier to understand and will be more obvious to start with factory example LifetimeScope. So let's create a new class and inherit from LifetimeScope. First of all, let's register our factory example service with lifetime.scope. I have explained lifetimes in previous videos in this series. Next, let's register entry point, factory example presenter, because we are using initializable and disposable. Now get component and cache factory example model. At the top of the class, let's add require component type of factory example model attribute. We can use our factory example model variable to register component. Finally, we need to register factory. Let's write builder.register factory with two types, vector3 and enemy. The first type is the input parameter, and the second one is the output parameter created via the instantiate operation. So let's write container and open brackets. Here we are able to return position, so our vector3, and use lambda expression to create instance of the enemy prefab at the given position and quaternion.identity rotation. At the end, return instance and specify lifetime, in this case it is scope. This registration enables VContainer to automatically resolve injections in the factory example service constructor after dynamic object creation. Finally, we can go to the factory example service. First of all, let's add a new private read-only func vector3 enemy factory. In the constructor, we will be injecting this enemy factory. In simple words, our register factory allows us to inject this func to the other classes in range of current context, in our case, scope. I want to also add short debug message about factory initialization. Great, let's implement public void instantiate method with two float parameters, spawn position x and z. I want to randomize this position a bit, so let's use Unity engine.random.range function and assign output to the random position. At the end, we can simply invoke enemy factory with random position parameter. It is important to note that you can have multiple input parameters, however, in the case of this example, one is enough. Okay, so let's go to the Unity editor, wait for the compilation process to finish. Now we want to create a sphere, our enemy, and add enemy component to it. Drag and drop this object to the prefabs folder and remove it from the scene. Next, let's prepare simply button, nothing fancy, so I will do it in the fast forward. It's time to create an empty game object called factory example. Let's add factory example LifetimeScope component to it. We need to pass references, button and enemy prefab, then set both of the spawn position parameters to, let's say, 5. Great! We can press play and check if everything is working. As you can see, I have my debug messages. Let's press the button. Yes, our object is instantiate. Also, the print message is shown in the console, meaning that the enemy is properly injected. Fantastic! Whether you are creating simple objects with runtime parameters or complex game entities with multiple dependencies, VContainer factory perfectly scales, while keeping your code maintainable and testable. I would like to invite you to support us on the Patreon, where you can get the exclusive code, all models, materials or code used in this series, and access to early available content. Link in the description. Thank you for your time, I'm glad you are with us and our community is growing. See you soon in the next video.